Hey guys, welcome back to Data Products. In this video we're going to be looking at what to do with missing values. And so these are values that either are blank or show up as an NA in your data set. So let's just jump right on into it. Okay, so I'm going to clear out my stuff here from my practice run. So the first thing that we want to do is create a markdown or HTML file here. We called this one missing values. So we'll say missing values. Oops. So if you encounter a unusual value in your data set and simply want to move on to the rest of your analysis, you have two options. One is to drop the entire row with these strange values. And so we can do this. We're going to use two libraries here, dplyr, because we're going to use the piping function, and we're going to use the ggplot2 because it has this diamonds data set that we're going to use for this example. We're going to say diamonds equals diamonds, and then we're going to say diamonds2 is diamonds, and we're going to pipe down, and we're going to say filter between y3 and 20. Okay, and before we do this, down in the console here, I'm going to run this diamonds so you can see. Let me move up here. So the diamonds data set is a data set containing the prices and other attributes of about 45,000 diamonds, and it gives us the price, the carat, the cut, the color, and the clarity, and then it also gives us the length in millimeters, the width in millimeters, and the depth in millimeters. So if we run this quick and we look at just the regular diamonds data set and we go by y, we see that we have 6 values, 1, 2, 3, 4, 5, 6, 7 values, that there is no width or depth or length or height or whatever the other one was too. It was length, width, and depth. So even though we have this carat, so 1 carat diamond's pretty big, but has no width, depth, or height. So what we did is we're going to write this function and spell it right. Diamonds. I'm going to rerun this quick. Diamonds2, where we said, okay, let's filter out our rows of data. And what we're going to use is the between function, and we're going to say for every value of y, we're going to remove it unless it is between 3 millimeters and 20 millimeters. So that gets rid of these values here. For y, we could use x or z for that matter. But it says if it's below 3 or above 20, which, let's see, so it filters out this one too, it's 50. So this diamond, okay, so it's like a long sliver. It is 2 carats, so maybe it's true, but it's 58 millimeters in width, but only 8 long, which is an interesting shaped diamond. So we're going to filter out any of them that are weird shaped like that. Okay, so we've done that, and so we've gotten rid of those rows. So that's one thing that you could do. In this instance, y is the width of the diamond. So anything under 3 or above 20 is excluded. So I don't really recommend this option because they're actually, let's change this. Just because there is one bad measurement doesn't mean they are all bad for that diamond, right? So instead, I recommend replacing the unusual values with missing values. So what you can do is something like this. Diamonds 2. So we'll actually make this diamonds 3 and not rewrite over our data. We're going to say it's diamonds. We're going to pipe down, and we're going to say mutate. So mutate essentially is to just replace y, and we're going to give an if else. So this is kind of like an if then statement, and we say if y is less than 3 or y is greater than 20, we're going to say give it an NA to y. So if we look at diamonds 3, you see we have the same amount of observations as our normal diamonds, but we should have, let's scroll all the way to the bottom here. Now we've replaced those with NAs, and you notice we've only done it for the Y. We haven't done it for the X and the Z values, but we could write the same thing for the X and the Z's if we wanted. Because those other values for like caret and cut and stuff, those might be good values for our data. Okay, so like R, ggplot2 subscribes to the idea that missing values shouldn't pass silently into the night. So what I'm saying is you shouldn't just I think it's better to not just get rid of them and to actually change them into NAs and acknowledge them, right? So what ggplot2 does is, let's try graphing. So ggplot data equals diamonds2, mapping equals aesthetic, x equals x, y equals y. Actually, this is supposed to be diamonds 3. We want to map with our NA values. And then plus geom underscore point. So if we run this, you can see that ggplot2 will tell you, it says it removes 9 rows containing missing values for the geom point. So instead of just ignoring the fact that you had missing values, it tells you at least, okay, these NAs we're not going to graph, but we want to let you know that they were removed. So if you want to suppress that warning, you can use na.rms, which is na remove equals true. So let's do that real quick. ggplot data equals diamonds 3, mapping equals aesthetic, x equals x, y equals y, and geom point. And this is where we would use, move my cursor so you can see, geom point, and we would say na.rm equals true. Alright, so if we did this, see, it graphs it and it doesn't give us the same warning if you wanted it to just not show up in your HTML file or whatever. Okay, so other times you want to understand what makes observations with missing values different to the observations with recorded values. So there might be some evidence in the recorded values as to why you have missing values, if that makes sense. So for example, in the NYC Flights 13, which we've used in the previous course, data set, missing values in the departure time, I think it's just up time, departure time, variable indicate that the flight was canceled, right? So there's no departure time, and so that just means that the flight never happened. So you might want to compare the scheduled departure times for canceled and non-canceled times. So what we can do is we can do something like library was NYC flights 13, so let's load that up real quick. And then we can do NYC flights 13, and then we want just the flights, and we'll pipe down. We'll say mutate canceled equals is.na for departure time. Sched hour equals sched depart time, and then we'll say 100 sched min equals sched depart time, and we'll say 100, and then we'll say sched depart time equals sched hour and sched min divided by 60. We'll close it, and then pipe. We'll do ggplot mapping equals aesthetic sched depart time geom freak poly mapping equals aesthetic color equals canceled bin width equals 1/4. Okay, so what does this Frankenstein plot do? Nothing, because I spelled something wrong. Let's see. Oh, maybe a comma there, I bet. No. Unexpected symbol. Mutate canceled equals is NA departure time sched hour equals depart time oh, I got my piping backwards. There we go. There we go. Okay, so we've got what we end up with here is, it says if it's canceled, we did a true false, and so we said, all right, our canceled flights are going to be any time there is an NA for departure time. And so what that's saying is, okay, for the scheduled departure times, we can see that there is a plotting here of the flights that were false for being NA. So these are the ones that actually took off, the red. And then the ones that are canceled are true. So is NA? And the answer is true. Yes, it is NA. So our canceled ones we plotted along the bottom. So I don't want to get too far into the weeds because this is flight data. It's not really pertinent to biological data products. But I just wanted to show an example of, okay, how could you use the fact that there's an NA value that might be something that you can actually parlay into something of importance. So in this case, because the flights were canceled, NA values means that was an identifier for us that the flight was actually canceled. And then we can graph it. So you can see that, there's not that many canceled compared to non-canceled. But down here in the bottom, you can see we have a few hundred at these different scheduled departure times that are canceled. Okay, so that's about it for missing values. You can use them, you can remove them. Sometimes they do tell you things like if a flight's canceled, you can use them to parlay that data. Other times you might want to get rid of them. Sometimes if you think that you got an NA value because your machine or whatever your data collection technique messed up, then it's possible that you can remove the entire row. Otherwise, you can save your data by just converting zero values to NAs, etc. So it's a good thing to know how to kind of pre-check your data before your analysis. So without getting more rambling, that's all I got for you today. I hope you enjoyed the video. If you're watching on YouTube, hit like, hit subscribe, and I will catch you in the next one.